podcast time.
So good morning, everybody. My name is Michael, and I'm the sales director for Optical Electronic Industries. Today we're having this stream and podcasting with Dr. Ram Hashmonai, our Chief Science Officer from Opgal, and together we're going to bring some more insights, we're going to talk about OGI equipment and OGI technology and how it is implemented in the industrial application. So, Dr. Ram?
Hello, Michael, and I'm happy to be here and talk about the technology. And I will let Michael lead the conversation. And what is your first question?
Well, basically, not all of our viewers are aware of what happening with OGI, how it's actually became implemented, and what is the historical background of this equipment. So on my end, I would like to give us some background on this historical background of leak detection and where is it coming from.
Okay, leak detection started in the 19th century. I cannot take you back over there. I'm not old enough. But methane emissions in the mines, in the coal mines in England and in Britain, they use a canary, and they used to go down with the canary in a cage, and when the canary stopped singing, they knew they have a methane concentration that is dangerous. So they got away. This is the first leak detection. I'll take you fast forward to the 1980s. EPA started the leak detection and repair program, which is called LDAR. And we're going to use LDAR from now on, not leak detection and repair. And this program uses point monitors. They call it sniffers. It's based on photoionization detectors, flame ionization detectors. What these detectors do, they measure concentration of gases, VOCs and methane. VOCs is volatile organic compounds to people who don't know. And they measure concentrations. They don't measure the intensity of the emissions, but people go around. And the regulation said you go around in a schedule, you go component by component, you measure concentration around it, and if you measure elevated concentration, you know you have a leak from somewhere in this vicinity. And this is how it started. And once you find a leak, the repair part of it, you need to fix it and then test it again and to see if the leak is gone.
So obviously, the canary story is very sad, though. But they had also, I heard about the soapy water that they used to put on pipes.
Yeah, this is operational. This is not regulatory method, but they still use it. They still use it. Sometimes when you use the old sniffer idea, and you measure elevated concentration, you don't really know where it's coming from. Then you use soap water around the pipe and you see where the bubbles come out and you know exactly where it is. But this is really primitive method, and that's why OGI came.
So that, saying that, I would be, kind of surprised if they have to carry a lot of buckets of water to the field every time that they have to do it. They have to do it in any inspection.
They didn't do it. They just assume they know where the leak is from, and then they try to fix it, and they make it worse. So it's like there are many cases, there are many case studies when they found a leak with a sniffer. They saw elevated concentration. They thought it's coming from one component, but it was coming from a neighboring component. So they're trying to fix a component that doesn't leak and make it worse. Sometimes a component that didn't leak started leaking after they fix it. And now there are two components that are leaking because they didn't know exactly where it's coming from. And that's the main reason OGI, Optical Gas Imaging, came into play. They need to visualize the leak.
So obviously measuring concentration on a certain pipe in a certain period of time doesn't really give you a holistic solution, doesn't really shows where the exact point of the leak occurs.
Yeah, It's not an efficient way. And another thing that they need to get really close. Sometimes it's dangerous. It's not safe to come and to really go to the point of release and measure it. If they don't do it, and they need to stay for a period of time around it to make sure that they know where it's coming from. They needed something more standoffish, like standoff methodologies that it can measure or detect the leaks from a distance. And that's another reason OGI is superior, and you can do it much faster. If you do it from a distance, you cover much bigger area in shorter time, and that's why OGI, they were looking for this technology for a long time. From the 1980s, it's only in the late 1990s that the first OGI technology came into. There were like these big cameras, and they had lasers. Some of them were active, and they had a laser that scanned the image and tried to figure out where the leak coming from. Very expensive, very heavy, not very easy to use.
Look into the practical part of this, technology implementation. It seems to carry in buckets of water and this huge equipment that you just mentioned. It doesn't seem to be realistic in terms of performing any elder activities. But saying that, the regulatory part, when it's really developed in the U.S. and how it just evolved with or without the OGI. And
It was beginning in the 1990s, no, beginning of the 2000s, like 2001, 2002, 2003, that there were a lot of presentations of optical gas imaging. They never called it back then optical gas imaging, they call it thermal cameras or imaging technologies for gas leak detection. And they started to present different technologies, but around 2003, 2004, a guy named David Ferry is not a scientist, he's just a guy he was a pilot, helicopter pilot that fly over and measure leaks with different technology. He said, why don't we put a filter on a thermal camera and try it out? And once they did it, this exercise, and compare it to all other technologies, he had no scientific background he just guessed that it would work better, and it worked much better. It was much more sensitive for any other technology that was presented before that. And the regulatory aspect of it, he went with the TCQ commissioner, and they flew over the whole ship channel in Houston area, and each refinery over there, they detected leaks from the helicopter.
oh,
And they sent the CDs to the CEOs of each of these, and this is what is emitted. And the next week, he was invited to the EPA to present it, and I was back then at the EPA, and I met them, and we sat down with them, and this is how it all started, the regulatory aspect of the OGI.
right. So, well,
It's about 2005.
That sounds like a magnificent story of the development, especially if it was discovered just by some, not a random guess, but it was a very lucky random guess, I would say. And again, in my end, that every facility, that they have the operational emissions, which is commonly, they are reported and they have be aware about it. But what about the fugitive emissions? Like, how do you get to all the fugitive emissions in one site? What is the strategy to get it? Like, if you said that okay, obviously we'll be flying around some facility elsewhere in Houston or Texas,
Yeah.
wherever it is, and if you're taking an OGI camera, you'll see a lot of emissions, right?
Yeah.
But very big part of them, they are planned emissions, like they are in the scope of the emission works of that facility, of a standard operational work, right? So what about the fugitive? What about the awareness of all of the non-process related emissions?
Usually, the OGI is only for the fugitive. When we talk about emissions of gases from this type of oil and gas facilities, we are not talking about stacks. We are talking about pipes and storage tanks, and we are talking about emissions from that. and they're always fugitive. And when you fly over, obviously you only take care of the big emissions, the large emissions, because you are taking it from a distance. The small emissions, you need to get closer with a operator, in the future maybe with a robot or a dog like that walking
Right.
around with the camera.
We're all going
But
that
right now
direction.
it's a person that needs to go and see if there is a leak or not. So the strategy, we can talk about the LDAR strategy. The whole development of the LDAR, what they did, they call it smart LDAR.
Right.
Once David Ferry and Ralph Marquez, the TCQ commissioner, which is the Texas Commission of Environmental Quality, once they came and presented it to the EPA, they started call it, instead of regular LDAR that use the sniffers, they started call it smart LDAR. But it was not very wise, because they did the same routine with OGI that they did with the sniffer. They didn't adjust the technology to the procedure. So the strategy should be much wiser, not smarter. So it's like back then when we started this in 2006, we arranged for a mini symposium about what we call smart LDAR, which is using OGI technology to detect leaks and repair them. And I presented a paper which I called Wise Continuous Fence Line Monitoring for Support Smart LDAR, because they didn't take advantage of the wide area and how quick you find the leaks. They still went with the routine component by component, when they can scan larger area with the other technologies and then focus in with the OGI very fast where is the leak, and not wait 3 months or half a year until the next time you take this. So EPA started in small steps, develop a smart LDAR, which is almost the same as the LDAR, but using OGI. And they call it alternative work practice. And this was published, proposed and published in 2008. But it didn't pick up just because it didn't waive the old LDAR from the industry. If industry chose to do smart LDAR, the alternative work practice, they still needed to do LDAR every year with the sniffers. They didn't waive it totally. And it took another 10 to 12 years that the EPA actually said OGI is more powerful. And then they started talking about alternative continuous monitoring methods, what I published in 2006, to replace the LDAR and use OGI combined with sensors and fence line monitoring to do a very wise LDAR, not smart LDAR.
Right. So for me, it's really a very good combination, and I do think that those shall be implemented and are already implemented in field, and it's really wiser to use a multiple techs instead of just relying on one thing. So the other question, like, but why were they so in this kind of hustle about this methane or the other VOCs? That's why is the environmental awareness became that high? What was the
Okay,
driver?
it all started with the VOCs.
Right.
Some of the VOCs are very toxic and have health effect, especially benzene. It's carcinogen. And they wanted to reduce emissions of VOCs and reduce the health effects of these emissions. And this is a very, I will not call it wise again, but it's a very, instead of measuring it and then give fines, that the concept, which is pretty good, find it and fix it, not
Right.
and reduce emission. That's the best for the environment and for the public health around these facilities. So that's how it started with VOCs.
Methane.
VOCs. I'm talking about now.
I'm
You
thinking,
remind
I'm
me.
thinking you to the
Now, methane is a different story. Methane is not toxic. We are actually measuring we are actually measuring in this room 2 ppm of methane every time, anywhere. This is the methane background. You have a high concentration of methane in the atmosphere. That's why it absorbs the radiation that coming from the earth and lock down heat in the earth, and it has a big effect on global warming, methane. So I will not go into the details how much potent it is in CO2, but methane became in the late, I think it's like 6-7 years ago, they have the UN methane pledge. They recognized that methane is the most important greenhouse gas to take care of its emission if you want to achieve what we call net zero by 2050 emissions of greenhouse gases that are contributing for global warming. So it's a global effort to reduce methane emission, and we can talk about it in the next podcast. But methane became later on very, very important, and in 2016, EPA first, they had the Quad OA regulation that it's for VOCs and methane. So the approach of EPA, the US EPA, is if we reduce methane, usually comes with a lot of VOCs.
Right.
If we are reducing methane for global warming, we're also reducing VOCs. The beauty of the sniffers and beauty or drawback of the sniffers depends on your perspective, is that both sniffers and OGI cannot differentiate between methane and VOCs. If you see gas in both instruments or technologies, it could be methane, it could be VOCs, you don't know, but you need to fix it.
Right.
So there are, sometimes you see VOCs and you fix it, but there is a lot of methane, and you also reduce methane emission by doing this.
Okay, so that actually drives me to my next question. So, who is the biggest contributors today to the methane production, or the methane, the methane issue in the world today? What kind of industry is really in that thing?
I'm a scientist with 30 years of experience, 38 years of experience in optical remote sensing and measuring these type of gases. I'm not the expert on this topic, but I have a lot of experience. The oil and gas industry
So the oil and
is
gas industry is the big.
the natural gas is for the methane. Natural gas has more than 80% usually of methane. The other industry that has the waste industry has like 50%, about 50% methane in the landfills emissions, but in agriculture, dairy farms, all kinds of animal livestock emissions, but these are the main contributors. Inside the oil and gas, we are talking about upstream, midstream, and downstream. So we're typically talking upstream and downstream of the well pads of natural gas in around the world, offshore, onshore. We have a lot of methane emissions from methane became an intermediate energy source until we go to renewable energy or hydrogen. It's a fossil fuel, but it's less toxic than the VOC, the gasoline and the other source energies. So it's like in transition, but now we use it much more than the gasoline and natural gas because it's more friendly as far as public health, but for the
Environmental perspective.
for the global warming issue, it's more acute to take care of these emissions. So
Right.
the move.
So, saying that, like, you would obviously it goes to this point where you would likely to use an OGI camera, which we just described was the most powerful tool to do that. But like, how is it changing the game within the methane regulation, within the oil and gas applications, maybe even in livestock? I don't know. You will tell me.
So the OGI camera is most relevant to the oil and gas because most of these sources are not diffuse sources.
Mhm.
When you have a livestock that are in
the field.
in the prairie, it's hard to, they producing a lot of methane, but it's really spread around, and you need a source that is concentrated. Also, a landfill, can come from many other, from the surface of the landfill. But what we are, oil and gas, it usually come from a vent, from a pipe, from a roof of the tank. It's a really concentrated emissions in a small area, and it's easier for the OGI to visualize it. So OGI is more relevant to the OGI industry, and not to the oil and gas industry.
Right. So, again, taking it back from what you just mentioned, and kind of trying to combine that like in a real lifetime application. So on my end, I can understand that like taking the cameras or taking the OGI equipment to those facilities actually giving you an opportunity, first of all, to what? Like, obviously, it's the environmental impact, right? So this is the major thing. But there's also also pros to use this equipment. For instance, like maybe there's losses, productional losses, or perhaps the maintenance cycles, whatever can be improved, or I don't know. Is there any other
Yeah, before regulation came, a lot of industry bought these cameras just to know what
safety, right?
It's not safety, it's just operational. They wanted to know where they lose product, where they have their leaks, to have better operation. It's not, and also to be like a environment steward. So the beginning or starting selling these cameras started much before regulation came. Regulation came really later, and this is a very powerful tool. You can measure from several hundred yards or meters, depends which country you are, but you just measure it, you visualize it, and you can do, nowadays you can combine different strategies also to evaluate evaluate the emission rate or the leak rate of each source.
Okay, so Dr. Ram, thank you very much for your time. It was a great pleasure meeting you. Hope to see you next time.